Next, we're hearing from REDstack. REDstack develops innovative electrodialysis membrane stack technology for efficient salt removal and water treatment applications, offering an alternative to conventional desalination processes such as reverse osmosis, and they focus on high recovery, low energy water treatment. I had the pleasure of reconnecting with Paula, someone I know from a long time ago, and meeting a colleague of hers to find out what's unique about their technology and where they're taking it. Tell us a little bit about yourselves and what REDstack does.
Thank you, Jo. It's great to see you again after too many years. I'm Paula González. I'm the CEO of REDstack.
I'm Hendrik Swart. I'm a sales engineer here at REDstack.
Amazing. And what does REDstack do? What's your value proposition?
Yes, REDstack develop and produce the best and most efficient electromembrane stack in markets. And that translates to the end customer into less OPEX, because we use 70% less of electricity in the process, and in less CAPEX as well, due to a very efficient stack.
How does it do that? That's quite a bold claim. 70% less electricity and 30% lower CAPEX. Those are big numbers. How do you do that?
Well, REDstack has developed through the years a new design for, let's call it the house of where the electrodialysis process takes place. And this is an optimized distribution flow system that is completely different to what we know in the market. Through this optimization and the design, we reach a better distribution that reach or delivers no leakages in the stack. And that is very unique. There is not another stack that can reach zero leakages at the moment in the market.
That's really different. And your main competing technology will be reverse osmosis, presumably. What's the main difference between RO and EDR?
Great question. The two technologies remove salts, but reverse osmosis do it by pressure, very high pressure. You take water and you force it through a membrane, while electrodialysis is selective because you use an electrical field to remove ions. That means that the water does not go through the membrane, but between the membranes. The advantage of using an electrical field is that ions will react to this electrical field. And this is a selective separation. We focus in the moments in the lower range of, we call it mild desalination. So brackish water that has less of 5 grams per liter of total dissolved solids, because then we see an advantage financially. But I think that Hendrik could take you through now into more detail of what are the applications.
Perfect.
Yes, indeed.
So, Hendrik, over to you then. Where does, presumably you're looking at applications like cooling towers and food and bev and pulp and paper. Can you talk us through where you think ED outcompetes RO and other technologies?
Yes, of course. ED has some clear advantages when you are looking at applications where there's feedwater with very low TDS, or if you have very limited resources, so you want to reuse the water as much as possible, then ED has the lower energy consumption than RO and can also reach higher water recoveries. And overall, the technology is a bit more robust, so it can deal better with components such as TOC, COD, silica, but also free chlorine.
When you say high water recoveries, what kind of percentage water recovery are you talking about?
It's mostly, it's a little bit related to feedwater, but in the end, you can always reach 80 up to 95% water recovery.
That's amazing. So what kind of applications are you currently focusing on?
In REDstack, we're mostly focused on industrial water reuse or wastewater effluent treatment for use in irrigation, but also looking at locations where it's very high silica in the feedwater, and that can then be treated very efficiently with ED.
Amazing. So I'm particularly interested in your application for agricultural water use, because agriculture takes 60% of most water allocations in majority of countries. Do you have an example of an agricultural or a horticultural application?
Yes, I do. We have one case study where we treat the effluent of a horticultural treatment plant.
What was the scope and goal of the case study that you're referring to?
Here we can see the case study of the salt removal of effluent of a horticultural, from horticultural treatment plant. They were dealing with issues and stricter regulations for discharge. So they were looking for solutions to specifically also remove nitrate from the water. And there we wanted to showcase that ED was a very suitable technology to provide a solution for this.
What kind of salt removals and nitrate removals did it achieve? Looking at the table, what was the standout achievement of this particular case study for you and for the user?
Yeah, what we very clearly saw is that we needed to reach a certain amount of desalination, 75 up to 80%, depending a little bit on the feedwater. But what we saw very noticeably is that it's very selective for nitrate removal. So with a removal of 75% of salt, we achieved a 95% removal of nitrate.
That's amazing. And what's next for either this particular application or in general? Because these are really high numbers. So what do you plan to do next?
Yeah, to see for other applications where we can implement this solution and get it to the market, of course.
Yeah, of course, we are also scaling up, right? And scaling up means to guarantee lower prices to the end customers. And for that, we are building an automated production fabric that we expect to be running up at the end of the 26, beginning 27. That is the current forecast. And that will help us to guarantee the quality that you need on this type of products, right? The reproducibility that you need on the low cost. And of course, we want to have in a couple of years many references and be able to tell to the world that we are the industry standard because this is the best electromembrane stack available in the market. So we want to see it running in many places through all the world.
Thank you, Hendrik and Paula. So RO is pressure-driven, non-selective filtration. It acts like a fine physical sieve, giving separation based on size. EDR is an electric field-driven selective ion removal process. It acts like a charged ion sorter, providing separation based on charge and mobility. The key message I'm taking away is that the right tool is needed for the right job. While RO definitely has its place, this ED technology provides a powerful alternative for different, equally tough challenges like brackish water desalination, boilers, and cooling towers.